Here the question is, we are given with a cylinder and this cylinder wall is completely non-conducting. Inside the cylinder there are two pistons and those two pistons are connected by a rigid rod. That means these two pistons move simultaneously. Now this piston right here, this is conducting piston, and this piston right here, this is non-conducting piston. So here the entire wall of the cylinder and this piston, these are non-conducting, and this one piston is conducting. So because of these two pistons, now it makes three chambers here. Now all the three chamber has some gas who have initial thermodynamic state same, P0, V0, T0 for all three of them. That means number of moles is also same. Now chamber 1 and 3, they have gases having same gamma value, which is 3/2, but chamber 2 has gas which has gamma 2. Now here in chamber 3 we are given with a coil also. So by this coil we can heat the gas. Question says, if this coil is turned on, means if we heat the gas here, then what happens at final state, means at equilibrium, this chamber 1 volume initially, which is V0, this comes down to V0 by 8. So the question is, if the coil is turned on, gas on chamber 3 expands till final volume of chamber 1 becomes V0 by 8. Means if this will expand, then this piston will move, then this piston will also move, and how long it moves? Till this final volume of this area, region becomes V0 by 8. It is asking find final pressure, volume and temperature of all the chambers. So this is the question here. Now we will solve this step by step. So take a minute and try to solve this problem by yourself. So let's analyze the problem first. What is it asking here? It is asking the final pressure, volume and temperature of all these. So let's think that what might be the thermodynamic condition which is same here, means initially and finally which thermodynamic condition is same. We can see that in chamber 2, see chamber 2 is made by two pistons, right? And this is a rigid rod. So it does not matter how much these pistons move. Think, if this piston move by 2 cm, then this piston will also move by 2 cm. So this volume will shift entirely. If this piston moves, this piston will also move. So the volume within this region will not change. It will remain same. That means this chamber 2 volume initially and finally, this volume will not change. But in these cases, they may change. So let's see what other thing is same. Now here for this chamber 3, all 4 side wall, they are non-conducting in nature. But we are given with a coil and this coil heats up the gas, right? So if this gas heats up and this expands and final volume of this one is V0 by 8. So decrease in volume will be V0 minus V0 by 8. This is 7 V0 by 8. So chamber 1 decreases by 7 V0 by 8. That means chamber 3 increases by 7 V0 by 8, right? So final volume of this one will become V0 plus 7 V0 by 8, which will be 15 V0 by 8. This much we can get. And here the final volume will be V0 by 8. Another thing we can say, see if this one's displacement, this piston's displacement and this piston's displacement are same, that means whatever work is done, means chamber 3, whatever work is done by chamber 3, that is the same work done on chamber 1, but chamber 3 is expanded, right? And chamber 1 gets compressed. So W1 will be negative and W3 will be positive, but magnitude of W3 and W1 must be same, because here the expansion and here expansion are same. Initial states are all of them, for all of them P, V, they are also same. So the P delta V of this one and P delta V of this one will same. So we can say work done of chamber 3 and work done of chamber 1 are same. So we can write W3 equals to minus of W1. This is another thing. Next, what else we can say? As the entire walls are non-conducting and this piston here, it is conducting. So if this piston is conducting, so heat transfer can occur through this piston, right? That means again, if through this piston heat transfer can occur, so finally whatever temperature this chamber 1 has, the same temperature will be of chamber 2 also finally. So chamber 1 and chamber 2, they will have same temperature at final state. Next, chamber 1 and chamber 3, they will have same pressure at final state. Why? As this will expand, how long it expands? Think, if this one will expand, so because of some force on this side, that's why this piston will move towards left. Now this piston will also move towards left. How long? Till the net force from the right side is same, right? So if force from the right side is same, then only both the pistons will stop moving. So if forces are same and area of cross section is same, that implies we can say force per unit area from left side is equal to force per unit area from right side. So the pressure must also be same in chamber 1 and chamber 3 at the final state. So these are the data we can think of from the question here. Next, let's see how to solve. Now here we can see this is the solution part. If this one expands, then yes, this is doing some work and we are writing it as W3. Now think, chamber 1 and chamber 2 combined. If we combine these two chamber, means this volume. Now in this volume is also completely surrounded by non-conducting wall, right? So net heat transfer for chamber 1 and 2 is not there. So whatever work is done on or by the system in chamber 1 and 2, here in this region, whatever work done means W1 plus W2, those total work done must be equals to change in U1 and change in U2. So W1 plus W2 must be equals to change in U1 plus change in U2. We can write like this. Why? Because these walls are adiabatic walls, non-conducting walls. So there is no external heat transfer through the walls in any direction, outward or inward. There is no heat transfer. So dq equals du plus dw. If we put here, dq is 0 for these two chambers combined. So du and dw must be same in magnitude. So according to this data, we are writing here W3 equals change in U1 plus change in U2, right? Now U, change in U is in formula it is given by NCV dt, right? So we are writing NCV dt. Now let's see what are the final states. So chamber 1, initially it has been P0 V0 T0, here P0 V0 T0, here P0 V0 T0, right? Finally, let's say chamber 1's pressure will change. Let's say this pressure, chamber 1, so this one's pressure will be P1. So we are writing at final chamber 1's pressure is P1. Now according to our concept that we just discussed before, this P1 and this P1, they must be same, no? At final state, pressure from this side and pressure from this side must be same, because at equilibrium net force should be 0, so force per unit area must be 0. So pressure 0, net pressure on the piston. That means from left side pressure and from right side pressure should be same. So here P1 and here also P1, these pressures should be same. Next, chamber 1 and 2, they must have same temperature because the wall is conducting wall. So I am writing here temperature is T1, so here also temperature is T1. Now here volume is V0 by 8, this is given in the question. Here volume will remain same V0 from the constraint of this pistons which are connected by rigid rod. So this rigid rod provides a constraint that the volume cannot change. So this one's volume is fixed. Now for chamber 3, pressure is P1 which is equal to chamber 1. Volume will increase to 15 V0 by 8 and temperature we don't know. So let's write it as T3. Okay. Now we will try to calculate. So we are given with W3 equals delta U1 plus delta U2. This is change in internal energy of chamber 1, change in internal energy of chamber 2. For change in internal energy, formula is NCV del T. So for chamber 1, initial temperature is T0, final temperature is T1. So we can write NCV value. CV can be written as R by gamma minus 1. So we are writing R by gamma minus 1. Gamma here is 3 by 2. So NCV dt, T final minus T initial. T final is T1, T initial is T0. So n CV dt for chamber 1. For chamber 2 also n CV dt. So n CV dt for chamber 1, n CV dt for chamber 2. By solving this, we are getting 3 nr dt. How I am writing n same for chamber 1 and 2? Because P0, V0, T0 are same. So if we put PV equals to nRT, R is universal gas constant. So this is fixed. Now for all three chambers, P, V and T are same. That means they must have n same n. So all these chambers have same number of moles. So n same. That's why I have put n and n here as same. So we got W3 as 3 nr T1 minus T0. Now we already know here W3 is equals to minus of W1. So we are writing W3 equals minus of W1. So W1 will be minus of W3, which is minus 3 nr T1 minus T0. So for chamber 1, we got change in U1 here. This is our change in U1. And here we have got W1 also. Now we don't know what process is happening here. How? Because in this there is no pressure constant, so this is not an isobaric process. There is not volume constant process here, so it cannot be isochoric. Temperature also does not stay constant, right? So it cannot be isothermal also. So what kind of process occurs here? Let's say some polytropic process, means PV to the power alpha occurs. PV to the power alpha equals constant. Let's say this kind of process occurs in chamber 1. So if this, we consider this is some PV to the power alpha equals to constant, then for this process our change in internal energy should be n R by gamma minus 1 into del T, and work done should be n R by 1 minus alpha into del T. This is the formula for work done in polytropic process. Now W we have already got here. Sorry, this is got here, but minus of this much. This is W. And delta U we have got here. This is our delta U value. So we have got delta U and W. If we take their ratio, then we will have a function of having gamma minus 1 and 1 minus alpha. We will have a function which will give us this ratio. Let's see. So for chamber 1, we are getting here delta U1 by W1 is minus 2 nr dt by 3 nr dt. So this everything got cancelled and we got minus of 2 by 3. So by putting the value, this is the value of delta U and this is the value of W for a polytropic process. We are getting 1 minus alpha by gamma minus 1. This much is minus 2 by 3. And gamma is also given for this chamber 3 by 2. Gamma is given 3 by 2. So by putting the value, we are getting 2 into 1 minus alpha is minus 2 by 3, or alpha becomes 4 by 3. So we got that this is process which is PV to the power 4 by 3 equals constant. This is this process. We got chamber 1's process. Now it will be easy to solve. See how. Now we will write for chamber 1. This is for chamber 1. We already know P0 V0 to the power 4 by 3 should be constant. So initial pressure P0 V0 to the power 4 by 3. Final pressure, let's say P final, into final volume will be V0 by 8 to the power 4 by 3. We need to solve this equation and we will get P final. From here we will get P final. See here, P0 V0 to the power 4 by 3 equals P1, which is final pressure, into V0 by 8 to the power 4 by 3. This gives us P1 equals 16 P0. So we got final pressure in the chamber 3 also. How? Because we have seen here this pressure and this pressure are same, no, finally. So if this is 16 P0, so this is also 16 P0. So final pressure here and here are same. Now again for chamber 1 itself, for the first chamber, again we can put PV by T equals constant because number of moles constant. So P0 V0 by T0 equals final pressure 16 P0 into final volume V0 by 8 into final temperature T1. So from here we get temperature also, T1 equals to 2 T0. So temperature of this chamber is 2 T0. Now as we know, this T1 and this T1 here, final temperature of both these chamber are same. So here also final temperature should be T0. So means we got final pressure here which is 16 P0, here 16 P0. This much we got, and here we got temperature should be 2 T naught and here temperature should be 2 T naught. This much we got. Now in chamber 2 again we will put PV by T should be constant. This formula will put for chamber 2. Let's see here. For chamber 2 we will put initial pressure P naught V naught by T naught equals to finally pressure P2, volume will remain same, so V naught, and temperature we already calculated here, temperature 2 T naught. So by equating this we got P2 equals 2 P naught. So this is the pressure in second chamber finally. So now we have already solved chamber 1 and chamber 2. Here pressure is 16 P naught, volume V naught by 8 and T will be 2 T naught. Here also we got this is 2 P naught pressure, volume V naught and temperature also 2 T naught. Now we need chamber 3 and chamber 3 P1 we already got 16 P naught. This is equal to this one's pressure and volume also we got. We only need T3. So again we will put initial PV by T equals final PV by T. So P naught V naught by T naught gives us P final which is 16 P naught into V naught, and V naught here, sorry, this is a writing mistake. Here V naught should be, our V naught should be 15 V naught by 8 by temperature should be T3. So by solving this, P naught and V naught got cancelled. So we got 16 into 15 by 8 into T3 equals 1 by T naught. That implies 8 and 16 got cancelled. We got T3 equals 30 T naught. This is the final temperature. So now we have got all the pressure, volume and temperature for all three chambers.